video series. And this particular video I'm going to talk about array jobs, and which is one of the batch job submission methods for accessing resources on a high performance computing cluster for running multiple jobs which are using the same script across the when we have multiple files containing exactly similar kind of data. In previous video we talk about single jobs, how to submit the single jobs, some methods of monitoring single jobs like sq command, scancel, sf to look into the efficiency of resource usage, and also looked into basically other as control show job id and followed by the job id number that to show more detailed information about any submitted job. So what has array jobs is, as I keep mentioning about, like when we have multiple files, for example here 4 files which has exactly similar kind of data in all of those, might be collected across 4 different individuals, so from 4 different samples, so that kind of data is same exactly across all the 4 files. Same I means in same kind of data, not exactly the same data, not identical but the same type of data in all these files. File 1 is fastq file, file 2 is a fastq file from individual 2's genome, file 3 is from individual 3's genome fastq file, file 4 is from individual 4's genome, and we want to do a qc across all of those ones, let's say. So rather than running one file at a time and waiting for it to finish and then run the second one, what we can do is run all of them in a single go by writing a one single script. And that's what an array job is. So the example we are going to look into is a again similar to single job array. We are going to do a fast QC over fast Q files, and here what we have is about 7 different fast Q files, including 00 up to 46. There is 47 different files, and they all are fastq files, and let's say they have and they have different kind of data between them, but they are fastq format files. We're going to run fastqc over them, and we're going to run an array job. We're going to submit a script. The script is pretty much the same as we saw in case of a single job. We have the first line describes the interpreter, the name of the job. The next line, then -o and -e describes the out and error file. So %x get replaced by fastqc, so it becomes fastqc underscore. %a is a job id number, so you will have a job id number here. And then basically the last %lowercase a is a sort of like a counter of how many times you have submitted this particular script. So we want to submit the same script, let's say 47 times, each time a different input as fastqc file, a fastq file. So it is going to, that's the counter is going to take care of it. Number of tasks, again as I mentioned, most of bioinformatic tools has only one task. We are going to use CPU2. We are going to run it in parallel. 2 gigabytes of memory. We are going to run on a partition MCB student. QoS is MCB student. So this is pretty much the same as what we saw in case of a single job. The additional flag or the additional we can say resource manager line what we have is #s batch. And here what you are telling the system is that we would like to run an array job from 0 to 47. Actually it should be 46 because 0 is the first file and 46 is the last file. Here the last we are running the script empty, so it should be 0 to 46. But if you specify more, it's nothing, is not gonna like report you an error, or it's going to run a job with no input file. So 0 to 47 jobs, then we are saying %8. Essentially what we are telling it, I would like to run 47 jobs, or I want to run I want to analyze 47 files, or want to run this script 47 times, but at any given time I should be running only 8, like out of those 47 jobs only 8 jobs should be actively analyzing the data or actively running. The reason behind that is just to have a control over, let's say some people may have thousands of files, so you don't want to run all the 1,000 files at the same time. It's sometimes it can just to be considerate to other users so that you not end up using all the resources. I could have run all of these 47 into a single go, that's fine, but I'm just being considerate. I'm saying at any given time out of the 47 only 8 jobs should be running. Once the first 8 finishes, the next one in the queue start running and get executing, so and so forth. And the host name, date, these commands are just so echo is something like print command in Linux, so I'm just printing the host name, the same as what it does here. The next thing which I want to draw your attention is to draw a dollar slurm array task ID. So slurm array task ID is sort of a counter which takes or which counts essentially how many times this particular script has been submitted. It's a variable that stores that value. So slurm array task ID, when it submits the script for the first time, the value is 0. So the slurm array task ID variable has a value 0. So since it's a variable, we put a dollar in the front. So all the variables in the Linux has a dollar in the front. And so the next is loading the software, which is module load fast QC. Then we are doing basically essentially the next line of code is nothing, but I'm just generating a sort of a you can say array or a list of all the files that I want to run. Okay, I want to run all these 46 files. So essentially ls-1, what it does, it creates a list or basically array or an array having all these files as a part of it, and whatever the array is generating, I am assigning it to a variable fast QC. So fast QC fast QS uppercase fast QS variable is nothing but holding all the names of all these file names are in the array format. So since these are, when we list them, they all will be present into this particular list into a very particular order. So always 001 will be the first one, then 0102 because that's how basically lexicographically or the whichever way Linux organizes these sorts them. So that's how these file names will be present into this list. So when we submit our as I mentioned that the slurm actually going to keep track of how many times it has submitted the job based on the slurm array task ID. The first time is going to submit this script, the slurm array task ID will be 0. Once it finished, once it's submitted, then it's going to submit the same script second time, because we are essentially asking it. Here I'm asking 47 times, so it's going to submit the second time. Then the slurm array task ID will be increased by 1, which from 0 it goes to 1. Then it's going to increase by 2. No, not 2. Again increase by 1. So the slurm array task ID becomes 2. Then slurm array task ID becomes 3, 4, 5, and so on and so forth. That's how it keeps track of how many times it has submitted the script. And every time the slurm array task ID, it submits the script again, the slurm array task ID increases by 1. The moment it hits 47, it stops at that particular level. No more new jobs are submitted. Okay. So essentially, because these list of these files are present into this fast queues variable in an index format, basically what I mean to say is all these file names are present in a list, and these in a list, these file names are nothing but the elements of, so each one is basically present in this list, and we can say, okay, this is the first file name, this is the second file name. So essentially when I say first file name, second, third, so on and so forth, what I'm telling is this is the index of that particular file. So the index of this file is 1, 2, 3, 4, 5, so on and so forth. So the first file is this one. So essentially if I tell you pick up me the 10th file, you're going to pick up this particular file over here starting from 0. So that's how you can pick it up. Now in case of Slurm, or in case of a Linux, when it try to pick up an elements of an array, it starts counting, or the index value, it counts from 0. The first entry is 0, second entry is 1, third entry is 2, so it goes start counting from 0. So essentially what we are doing in this line, most important line in this case, is here we're creating the list. We have a slurm array task ID, and here what we are doing is essentially picking up an element from fast queues based on whatever the value of the slurm array task ID is. So let's submit this job first time. Okay, so let me explain that way. So let's submit this job for the first time. So again, reminding you that the indexing in Linux is 0 based, which essentially means the first entry in the first entry is the 0th entry, then the second entry is has index value 1, third entry has index value of 2, and so on and so forth. Okay, so for the first time when the Slurm is going to submit this job, the Slurm array task ID will be 0. So when the slab array task ID is 0, and here I am saying from the fast queues, from fast queues, which is from this list, pick up the 0th element, which is the whatever the value of the variable slab array task ID is. So here the value is 0, so it's going to pick up the first file, and that file is going to become my input file, and that's what I'm using in over here, and the script would be submitted. Once the script is submitted, my slurm array task ID is going to increase by 1. So my new slurm array task ID becomes 2. So here A become the new slurm array task ID becomes 1. Sorry, because the previous one was 0. It's increased by 1. So new slurm array task ID is 1. Here it is going to become 1 1. In previous case it was 0 0. So it becomes 1. Now in the fast queues, I am picking up an element whose index value is 1. So this is 0 index value, this is 1. So I'm picking a new file this time. Take that file and submit the job. And then again the slurm array task ID increased by 1. So now my new slurm array task ID is 2. Now again this replaced here 2. And from the fast queues, I'm going to pick up, from fast queues, I'm going to pick up the element whose index value is 2. So 0, 1, 2. Now I'm picking up this particular file. Now this time this becomes my input file. That input file I'm providing here in fastqc command, and that script is being now submitted. So this way, every time the slurm array task ID will increase by 1, and every time we have a different file as an input. And it will by the time it finishes submitting all the jobs, all these files has been basically has been processed using one single script. Okay. So let's go back on the cluster and look at our script. So it's a ls, and we look into less of fast queue array. And if you look at, that's pretty much the code it is. There's not much of a change. ls-1 is nothing but to list out only the files. It's a way of listing the basically files which ends in .fastq.zz. That's how the files are, the fastq files we want to carry out fastqc on. So let me list those one, fastq data. That's it. These are the files. These are in the fastq data folder. So the command which I'm using there is ls-1, and then I'm using ./fastq data, and then star.fastq.zz. That's the command is. So here I think that zz part, no, here it is. So basically nothing. This is the command which is I'm executing, and whatever is the output of this command is stored as a variable in the variable fastq. So let's see what's the output of that one is. If we hit return, these are nothing but the name of all these files. Those all file names will be, and basically is 000102 and so on and so forth. So let me submit this particular script, ls, and I'm going to say as batch and fastq array .sh. That's the script we saw, and hit return. Now if I go and look at sq, it's going to tell me that so now submitted from 0 to 46 jobs, because in this script it's 46, because in the slide it's 47, here it is 46. So now 8 jobs are running, 0 to 8, but the other jobs are actually in the pending state. Basically they're waiting for finishing. They're waiting to be other jobs to finish before they start running. So now let me do again sq quickly. Oh, it's what happened? Okay, that's fine. Okay, so the jobs which we are running is 0 to 7. 8 jobs were running, and the status of these 8 jobs is R, that they are running. They're running on Xanadu 71. Others are pending. Here now, those 8 got finished. The next 8 actually start running, and if I run again, now essentially they shouldn't be. For some reason they're waiting, but they generally don't wait for all the 8 to finish. Even if one job finished, let's say the 0 finished, _0 finished, then _8 will start running. But any given time, only 8 jobs would be in an active running state. So that's how you can run basically an array job using the same script but have multiple input files. Again, you can use the commands like sq to look at the status of your jobs. Okay, so basically I have now 32 to 46 jobs are still pending, so it's looking for resources. Once they are available, they will start running. Okay, so they start running now. So That's how so CG, if you see so the status what we have so far seen is PD is for pending, and you're pending for certain jobs, like the resources are not there, or the resource manager is waiting for the resources, and R is when your job is running. CG is when your job has finished, and basically the system is actually finishing up the job. Sometimes it's cleaning up the temp space or so. Okay, let's go and look at SQ. Everything is finished. And now for each submission, for the zero and the different input file, we got a different error and different out files. So that's how basically a array job works. So what we looked into this one is basically slum array task ID is a variable that keeps a track of how many jobs are being submitted, and based on that slum array task ID, it can pick up different files from your input. You don't have to use that command. So we could have created the fast queues variable as simply by using specifying file names inside one. So we can create file 2, file 3, file 3, file 4. So if you, in your script, if you have, let's say, only 4 files, rather than using ls-1 star blah blah blah, you simply can have all these 4 files listed one after the other in the parentheses. Those are important. The parentheses are really important, and you can have this one in place of here. If you have just 4 files to run, you can simply create, rather than using this code, what you simply can do is list out as a name of any variable. The fast queues is a variable, I have named it, but it's an arbitrary name, you can change it. And essentially you can have a variable, here I'm using fast queues, and you can, files can be listed after one after the another by separated by a space, and have a parenthesis on either side that you can replace here. And then because you are submitting only 4 jobs, I will going to say 0 to 3, and maybe not use %, because there are 4 jobs. And then you can submit the same script. Then if you have those 4 input files will be used as those 4 input file will be used as input, and the sub job will be submitted 4 times. So this is pretty much about around slum array job submission.